Well, from right lane to left lane, it's not a left lane, turning right, you go straight. So, for the left turn signal. Yeah, the intersection.
So of course, I'm going to do CIS. Which is not definitely going back to the capital, so it's still like it's not.
Okay, good morning. Yeah. Do you remember on Monday we already tried to connect to the server and just try to like set up some basic, try to just let you to log in using your public key. Today we need to maybe go through some like basic vocabularies, like really something we will mention a lot and we use a lot for cybersecurity. So for today, sometimes we talk about the network interface. So the network interface we are using, that means like which the data. So we're going to transfer in or out of the computer system. And it can be exist like for the network interface, can be a hardware layer, or like even just as a software. So why not? Because when we're using more like virtual computing, so kind of like hardware on the virtual the machine is simulated by the software. So when we try when you look at your some of them already create the EC2. So you see the public and then there's a private like the virtual IPv4. First for our network interface would be the maybe the LAN card adapter. So maybe when you look at your computer, you should have a there's a pub it's the for the Ethernet cable. Yeah. So most of those will be like more like physical. It's called a hardware network interface. So when you plug in, because all those ports they have called a MAC address, and those MAC address will be like unique. All this unique. So when the router like detect there's a connection, so it assign IP address to it. When we create more like virtual computer on the cloud or like if other VM, when we come to connect to the internet, it also try to get the IP address. And those will be like handled by the just like software layer. And when we talk about the network, we will know one is called the LAN, one is called WAN. WAN is called the world area network, and LAN is the local area network. So before I go to definition, who knows what was the differences between them? Yep. Okay, pretty close, yeah. And when it's more likely, well, it's like outside of the network. So if you try to connect, because we have called that like local area network, just like if you have the something we call the gateway. Yeah, I will take an example as a router. Okay, the router can be your gateway. As one of your gateway, when you plug if you look at your router, sometimes there's a one Ethernet port. It's like in different color, and maybe it comes with like 4 others like we call switch. So the one is like always marking as a WAN. So the WAN is like coming from outside, like yeah, okay. So it's something we call the internet, and all these local areas just like in your I say sometimes based on how we define a DNS, or sometimes we say that subnet will be your local network. That's like inside. So right now we have the this campus, right? We have a router. Suppose it's a router, and then we have a lot of APs. APs will be the access point. So all those access points all connect to the router, and there's only one router. So all the devices, like no matter your laptop or some desktop or your cell phone, all connect to the internet. We are under this LAN, the local network. And when we try to go out of this LAN, that means the WAN. So all the LAN form together, so we form a WAN. So it's a concept. And right here. And next, like how can we really communicate? Like we're sending out, if you send a message, hello, from your maybe computer email, send it out, we always like change it to a package. All this package will be also sometimes we say it's a kind of a unit of we sending out. So even it's just like sending a hello, in this package we have the sequence, like maybe we'll trap it in several package and send it out. And it's it's kind of like it's an envelope, so we have the header and then content, so we know it. And average, when we send out this like all this a message, so we just think about we need to know or if you send a mail, a letter to others, what kind of information you need to provide? You need to have your destination, right? And from destination, you should know like who is the receiver and what's the actual address. And also sometimes we'll contain the sender's information. So it's the same idea if we need to send a package out. So if we need to send a hello message to somebody, then always we'll know, okay, the router need to know, okay, what's the destination IP? Is it inside your local network, there's the LAN, or it's going outside of your local network? That means I'm going to send out to the WAN. So based on the package, all this address will determine like where should we send out the package to. Okay. And when I mentioned sometimes it's called the host, it can be like any devices on the network. So you can be a server, it's a computer, your laptop can be a host, and even your cell phone, it can be a host. And hub, that means like they will take the package and repeat on all the ports. So all those like hubs like you can pop in, so they can be the hubs. And switch, so they also like only like taking the package in, and also with the MAC address. MAC address is like all you need for the computer. So MAC address kind of like is a physical unique number for all the hardwares. So when the manufacturer produce like all those hardware, you come with. So no matter you buy a network adapter card or USB Wi-Fi adapter, they always come with a MAC address. And another upper level we call the router. And all the router they will really handle is called a routering. So we with the IP address, sometimes we know the destination. And also we will say is the routing information protocol, like RIP. So it's like, okay, where should they send all those package to? Here slightly maybe try not to confuse you. We talk about a lot about router. And if you're using the one, say we have a router at home, actually it's not only router. It's a combination with router and switch. Okay. But for the router, the only function is like in the top layer handling all the like based on the destination address. So it's called routering. So like when I receive the package from outer network and I need to like forward to some your local devices, or from your one of the device from your local network send to another device in your local network. That's the router function. And but for the house router, I say one of the port is called WAN, and others like connect some connect to the LAN, like other maybe your computer, or you have a printer, or maybe you have any other like smart devices need to connect to the internet. So that part is called switch. So the switch itself is like just determinate, just like it's more likely is like it's a gate like open, let you go in, pass through, and build up the connection from A devices to B devices. Yeah, so they were like different type of devices to connect switching. Yeah, just like build up a bridge and connect it. So itself, it doesn't have a forwarding the package function. It cannot determine. It can more likely is the physically, like sending a signal 0101 to other devices. So that's how it works. Okay, and we talk about lots of like those like physical like hardware. Then when we have hardware, then we have a communication between all devices. Then we should have a protocol. And the protocol we talk about, so it's a more likely it's kind of like define language and let all the devices can use to communicate. And actually we use a lot protocol in the networking based on the purpose. So later probably you'll hear a lot like different protocols. And the ports, that means the ports will be the address of single machine that can tie to a specific pieces of software. So it can enable the computer to communicate with like other application. So in the port, it's like not really no interface involved inside. And if you remember on Monday, I say we do the SSH, right? So I mentioned port 22. So it's a standard. Like if we say we need to connect through the SSH, then the port 22 should be open, enable. And for the website, we say always say HTTP. HTTP default is port 80. So you cannot change it to other port. So it's a like kind of under the protocol, right? Okay, port 80 is it. If we say we include the SSL, the certificate, then we are not using port 80 anymore. Then we should using, anybody know if we are using SSL? Anybody know which port are we using for the HTTPS? No, it's 3 digits. Yes, correct. Yeah. So 443 will be for the this port is for the HTTPS with the certificate. So even you just say, okay, when you type like www and then or like without HTTP or with HTTPS, you will see when you it will redirect you to certain like domain. In behind actually help you also handle those ports. So if here's the question, maybe somebody install I will after I mentioned talk about the port, I will go back to the EC2. Anybody able to access to the Nginx website?
I was never able to reconnect.
Okay, none. Oh, ever.
Oh, not spot.
Okay, I will see because after that I will let you try one more thing and then decide. Okay, you already able to make it. Okay.
The Nginx will allow open SSH.
Yeah. Okay, because in the class, yeah, I talked about in yesterday's class about that one, but not in this one because I want to let you and try by error. Okay, so in this one is like I just because for the cow, I don't want to spend too much time to let you try. Just let you know. Okay, just enable this because we need to work on something else. But for the cybersecurity, we need to know what's a port and then how can we open it and about the firewall. So there's a reason why we couldn't like in I say on Mondays lab we couldn't access the Nginx like welcome to Nginx website. If you check the D2L, I upload one is called the EC2 and one is called the Ubuntu, the PDF. So you can see the screenshot I already upload. So you once like install everything, including the Nginx, you should able access. I didn't tell you how to make it, how to do it. So I will cover this part like by the end of this lecture. Also, I'll talk about the assignment like details. Okay. And right here is about the port. Like you should know, like I say, which port we are going to open. That means this one. NAT called the network address translation. So basically just about like translate the request incoming from the routing server. to device or server know about the LAN. So we're doing the translating. Okay, we go to which one. And if they're outside the LAN, that means they're from the WAN, only the public facing address of the NAT, that means the router. Then they will like, when they receive the package, so they will try to like send it to those like destination based on the port or like which one we requested for it. So it will take care of it. Mainly we will do it in the router layer. Okay. So it kind of like we have the mailing room. If you want to like need to imagine it, this is called NAT, is like you have a mail room, and then for a large organization, all the letters, they will go to this room first. So, and then based on, they will check, okay, maybe this one is go to that room. And then, so it's kind of similar. If we have multiple rooms in this organization, it's representing your devices. And in which room you should have a number, right? The room number. So it's same, have a same idea. But to the public, when the package comes in, they only know goes to the mail room, but they don't know how to go to your like specific room, right? So always maybe they try to deliver some letters, like something here. So they have a mailbox right here. So they will just put everything in the mailbox. So come here, because they know, okay, it's a room 335, but they don't know which actual location where is it, and how can I take it from here to there, right? So they always take the mailroom. So inside here, maybe there's an admin knows, okay, when it goes at 335 should be in the third floor and then behind. So they say kind of a similar concept. Get it?
So with the NAT, there's like different types, right? So like open, moderate, and strict. Is what I've seen. So like what do those different types like entail? Is it like what devices can see your device too much? Or?
It's not about can they see your devices, but mainly from how do you assign the IP address to all the devices? Actually, if you some like from other server want to send you a package, right? Most of the time they only can know is okay from this public IP address request for certain information, so they will send it to here, but they don't know how to from the destination server. They only know the WAN layer. Do we get it? So they don't know like all the devices behind this local network. So they cannot say, okay, let me go to which device. So they always need to like pass it, and based on the NAT. So they say, okay, if this package comes in from this one, it's like, okay, device A request for this one. So I forward to this IP address. Can you like get it? Okay. Okay. And we will talk about the layers. So many layers, like higher layers is more like on the surface. On surface like software. But when we like going down, so it will be like more like really physical, like the hardware. If we talk about a layer 7, it's really actual applications. And we will see, okay, we can see like the human computer interaction layer, that's right, application. And presentation layer is like ensure the data is in usable format. So where the data encrypt. And section layer maintain the connections and is responsible for controlling ports and section. So right here, and then transport layer transmit the data using transmission protocol. So we heard the protocol, right? So for the transmission, they do have their own transmission, their own protocol. So they have their own way to communicate. And in here, if you heard about TCP/IP, UDP, then we'll be in layer 4. Have you how many people know what's TCP/IP or UDP?
Oh, I know.
Okay.
It's different ways of like how they structure the packets. So like a UDP packet is slightly different than a TCP packet with like how they're formatted. And then if I remember right, UDP it just kind of sends all like more of the
Mhm,
data at once, so it's faster. But you can have more risk of like data being lost.
okay,
And then TCP, it'll send it more in like kind of waves, it'll verify
mhm,
the receipts
okay, yeah.
before it sends the next one.
Okay, yeah. So that one including like we call the handshake. This might make sure that your destination, the receiver, like it exists and ready to receive the package. So of course we have different purpose like using TCP or UDP. This one way because say okay, if we are using UDP, if we will have a risk to lost data in this transmission layer, then why we are using UDP? We'll talk discuss up this part, but before we go into it, okay, then do you know what's if UDP will have a risk or potential to lose the package? This is what we don't we don't want to. Then why we still have a protocol? Use this one for transmission. Do you know what's the possible reason? Like why we are willing to taking a risk to lose the data? Okay, first. Okay. Do you know one of the example using UDP? Broadcast, yes, correct. Yeah, because like for the broadcast, we don't really care about, okay, in this moment, if I lost the signal, it's a black screen, it doesn't matter because we want to just let it keep going. Okay, but for we downloading a file, we cannot using UDP. If we just like even miss a bit or lost a one package, then the file corrupt. Have you ever seen like or like have you ever experienced if you try to download a packet, a file, have you ever like it just like say it's corrupt, it couldn't open? Except sometimes the file itself like have some problem, but sometimes because in the during the like transmission, some package, yeah, we lost. But say even like use TCP, is it possible to lose package? Then you say we are using the protocol, this protocol. Is it possible? Okay.
It'd be more on like the actual connection itself rather than protocol.
Yes, yeah. So it's like go down more to the physical layer. So it will be in the lower layer. So we'll go down to the network layer, which will be know like which physical path the data will take. So we are sending by which like path. Maybe somebody right now you can connect with the like LAN or Wi-Fi physical cable, so we can know which interface we are sending out. And then data link. So the format of the data. Okay. So you know when you type something, we are all convert to a bits, right? Like 0101 and then the package. So it's called a data link layer. And really actually how we send out your data will be the first layer with the physical layer. So it was sending the bits streaming over the physical media. So mainly we are using the Ethernet cable or the copper cable, or sometimes we're using the optical fiber. So they are same. So here's all the layers, including like for the network. So you see, we have total 7 layers. We try to define 7 layers for internet. So when you try to send out something from your application, from what you see, press the button, send it. So we have different protocol and try to transfer to like 0101 the bits, and then send out through the sometimes through the like electric signals like 01 with like based on the voltage, some the voltage. So it changed, then we'll know. Okay. So right here, it was why not the more like conceptual framework. So in this layers, sometimes we ask like maybe for this when we are using, okay, which layer does it belongs to? Okay, so just remember, and always like top to the bottom. And in the application, mainly links the user and the information and provide the meaning, like actual meaning of the data. So how it translate, and then presentation, then we'll convert the data maybe from the compressed or encrypted code form. So we need plain text, just a text, but without like some format or some like how does it show up. So it's a presentation. Maybe this one maybe confused a little bit. And here exactly in the section, so they were really like in their trunk and across different sections or based on the section. And right here, the transport layers. So it will support the like reliable communication over unreliable medium. Okay. And we have that synchronization and acknowledgement or sending, receiving. So we talk about TCP/IP in the transport right here. Okay, so it's right here. Network layer, so we need to know the address, routering, actual path, and then we need to detect the collision. So sometimes when they have like two devices want to send a package in the same time, so we should have some protocol, just like the signal light, right? The signal. So if we have some cars over there, sometimes we using stop sign, sometimes we use the traffic light. So all this kind of like the protocol, how we manage all this. And if I'm sending this data, like based on our destination, how can we forward those package to? So are we like sending to specific, we say the host, or are going to like broadcast to all the devices? So it depends on which one. And really, they change it to just 1 and 0, and they will just like we combine in this layer once we receive it. And physical layer, we are really sending it based on the light. The light will be the optical fiber. Voltage will be the it's the same. We're using the Ethernet cable. Right now we are using the Cat6, like Cat5 or this one, or the Wi-Fi is also is a medium too. Yeah, so sending by the wave. And this is how does it really goes out. So if we have two routers, and then from your computer, we send out like from the epic. So it's like top to bottom. And then from another router, when we receive it from the bottom to the top, so we and keep going up. So decrypting. So one is called encrypt the data, and one is like decrypting. Okay, this. And sometimes when we have a network devices, like all your devices should have a unique fingerprint, just like we have like, how can I know who I am? Or why now we have so many, even in this classroom, we have so many laptops right here. I think also maybe your cell phone also connect to here. So how can we recognize, like make it distinguish, like, okay, this you. And so you're here, what I mentioned is called MAC address. So MAC address is 128 bit number. So some of we also represent by the 6 hexadecimal pairs. So first 3 normally we will know the chip manufacturer, and last 3 is unique to the device. If you but some maybe if on your computer you will see maybe they will print on the label, but maybe no. But you can able to find your MAC address. Also, if you want to set a static IP, then how can we set it? So we always say based on your MAC address, we recognize, okay, this device, this your device, and then it's your MAC address. Then when I know when I connect to this device, so they always say forward the MAC address. So now, okay, I need to assign this IP to this one. Or when I forward it, I will know, okay, to this IP, send it to this device. So it's the MAC address. We cannot modify the MAC address. Suppose we are not allowed to do it, but actually there are some application to pretend or like help you to modify your MAC address.
Does that actually change MAC address, or just kind of like you put on a costume with like a different MAC address?
More like this way. Okay. It's like because a MAC address really burned to the device. So because when the manufacturer need to produce like maybe but they will do it separately, right? Even though your maybe MacBook or Windows or the different brands laptop, when they produce your motherboard, also they may be embed the LAN adapter with your it doesn't have it, but for your Wi-Fi chips, they also have their unique MAC address. And this MAC address, like you can see, first three will be representing the company, so you say always the same. So then we'll know, okay, if this first 3 digit I know is like produced by this manufacturer, and last 3 will be okay, this device. And we cannot change it. You cannot say, okay, when I change it. But then answer the question is like, sometimes we can pretend or make a fake address. If you can do it on I remember you can change it on Windows. Windows allow you to change it. There's a software, but it's like on the software layer. So it's kind of like, I need to tell you, okay, my identity is like this. But I make a fake passport like this, fake ID card. So I give the fake ID card to others. So it's still possible. So then you can get the new IP address. I did this because sometimes long time ago, when you need to, some website will detect your IP address and limited your access. Sometimes if you want to buy something like limited, or they are not allow you to like keep access it, then they will block your IP address. They don't let you to do that. Then actually you can do it on the software layer to pretend, okay, I change it. Why we can do it in this way? It only just like let your own router to think you are another person. So I give you another new IP address. But sometimes you need to like change it back because it will cause some issue. So it's just like kind of like software layer to pretend your MAC address change, and then the router did, okay, here's a new device that I give you a new IP address. But later you have to change it back. Maybe sometimes it will affect your like communication like inside. Okay. So for the IP address, we have like 32 bits. So this is called like IPv4. So when we if you remember the EC2 is shows like public and then your private. So it's called IPv4. We are from like 000 to 255. And we can do it like static, so we can like fix it like based on the MAC address, like assign to it, or dynamic. So how can we do it dynamic? So we need to call the DNS, but later we cover it. And we do have a private IP. So did you check like what's the range of the IP they're using in the campus? Do you know how to check it? Okay. So what's the IP they're using? Like what's the IP they're using for this campus? Anybody?
127.0.0.
Okay. 125. Yes. If right here I can do it. Okay. So can you see? So we are IP address, we are taking the 10. So most of the time we are using for organization, they love to using start with 10. And for the home, and here is the router address. So they can define the router address by this one. So it's 10, 128, 128, 128. If they do have an interface, let me try to do it right here. Okay. They're pretty nice. They allow us to see the interface right here. So if you type the IP address, so here's your router. So they're using Cisco. And right here, it shows some, I think, allow for public to access. So suppose they are not allowed, most of them, they don't only set the login for the user. So, but I think they just make it accessible like to others. You can see, okay, right here, they will show the client IP, and then and then which AP radio using, and then the band is we are using the 5G, and then the channel 112, and then we are using the AC format, the mode, and what's the maximum bits we can say. Okay, so and then here's the strong of the signal. It's like 47, I think it's like 46 to 47 dB. This dB will affect by the distance. So I think, can you see any router, the AP right here? No. Okay, over there, okay, I see the white one. So it's pretty, if you have the AP in your home, suppose the signal is like pretty low, like pretty when we are close enough, so that the dB damage signal is pretty strong. If maybe most of it in your house, maybe you only have one router, but it maybe middle of your house or corner of it. When you get slightly far away, you will see the dB. That means the signal it drops. No, it drop. It goes higher. That means we have a lower signal. And also we can run the speed test, and then here is the AP we can access. So we have the 2.4G and 5G. And right here, the signal, okay, it can show the traffic. So for the enterprise level, they have a more like stronger, they have a chips to handle the connection. So enterprise, they always able to support maximum, sometimes more than, for one day, can support more than like 1,000 or 2,000 clients. They can handle in the same time. But for your like home router, so they have low performance. So they cannot like handle so many clients. Even you can set a lot IP address, but we can't really like, because they have the maximum processing power because of the chip, so they cannot do that. And then right here, so when we transfer all the bits, actually when have digit, they most of the time we will say it represented by the decimal number. So you will see it's like 10, or like for your router at home, it will come out most likely like 192.168 .1.1. So the format would be like this. And we heard a lot about it's like IPv6. It comes out IPv6, and if you check the EC2, they also have our IPv6, or like we allow IPv6 access. If we reject it, then we cannot access.
So
yeah.
if dynamic means it's changing, how come the IP is the same?
Yes. How? There were like sometimes you say, but I sometimes like I always get the same IP right address. Then how can you do it if it's dynamic? Open question. Yeah, you can discuss. If I say it's a dynamic IP address, then suppose it should be changed, right? So you won't get the same IP address every time. But most of the time you will get maybe in the campus you will have a different IP address, but at home you will see most of the time you have the same IP address. Then do no one guess if it's dynamic.
If your device is like a recognized device on the network, then it just be one of those. It's like, okay, just give them the same IP again.
Yeah, sometimes actually we have a cache, like inside the router, they also have a cache. Like they will save based on, they are kind of like mapping. So then okay, this device will map to like have this IP address before. So sometimes it will assign the same, or we always set that called the lifetime. So will this IP address last how long? Maybe you can set to only 1 day. Suppose like they will clean all the records. So once you disconnect and connect back, they will assign another new IP address to you. But if you're getting, let's say, why I always have a same IP address, I won't say just lucky. No, yeah, unless you set the static IP. So once we just bond it, if for this IP address, I only assign to this MAC address. So we will reserve this one. So we are not going to assign the IP address like you already set it on your router to that specific MAC address, that device. If let's say, then if I connect to Wi-Fi, using Wi-Fi and the Ethernet cable, then how many IP address will you get? If you are using your laptop, so you plug your Ethernet and also you connect to your Wi-Fi. Here's a question. Then how many address will you get? Okay, good. Then if I want to get a static, how about static? Should I only set the only one, or I need to do it separately? Yes. Yeah, because we say we only recognize the MAC address, and the MAC address is unique. So the unique is not unique to your physical device, the laptop, but also because we say the port interface. The interface one is the physical one of the physical interface is your LAN port. Another one is your Wi-Fi chip. So there are two different we say the hardware interface. So they have their own MAC address. So that's why when you connect those interface to the internet, like to the router, then they will recognize they are different things, even though it's the same device. Yeah. And that's why we need to say that in the layers. Then back to the layers, we know that we have 7 layers. If you are sending a package, let's say if you want to send a message, but you are connecting with the Ethernet cable and Wi-Fi, then but we are the same actual notebook, right? Your laptop. Then how do they handle it? You know how we did? Okay, so are they going from the Ethernet cable, Wi-Fi, or are they sending out by the both of them? And if there's somebody reply to you, are they sending back the package from the Wi-Fi or the Ethernet? Which way? Or like how does it work? Anyone want to guess?
Usually it prioritizes the wired connection.
Yes. Yeah. So when you connect, even though you will receive 2 IP address, for the system, they always say have a high priority is a physical cable because it have a stable connection and supposed to have higher speed. So they always go to that one. So kind of like the Wi-Fi, even though you connect to the Wi-Fi, it kind of back up. So we are not really using it. Yeah.
So if you're connected like the Wi-Fi and wired, they're the same network, but different ports. Is that on that network, or is it just to do with the interface?
Because sometimes we're using port is confusing. We are sorry, yeah. But
not like physical port, like plugging into the
yeah.
port, but like
yeah.
It works in the computer, right?
Because sometimes you will hear and say like port. I know it's confusing. Here the port is we say the port is like 80 and 443. Those port is like kind of like software layer. Sometimes we say like in the port is like physically. Yeah.
like
So I try to make it like sometimes we call it just a port because more like communication with but I try to use it as an interface. So you'll know more like interface is more like it's a physical layer. Okay. So are you asking the interface one?
Yeah, the interface.
Okay.
Not the actual like plugin.
Okay, yeah. So for the interface, but based on what I asked, can you guess like which way? Like if you let yourself think about it, you can. Will you just ask a question? So how do you think? If you're
I guess I guess it was mostly like with the IP address, so like, cause you have the different IP addresses, and that's just because the wireless and the wired are different on the interface. So, but they're still the same network.
we are under the same network, yes. Yeah, so we are LAN, right? You remember, like, first we talked about WAN and LAN. So WAN is more likely the outside network. So connect, so LAN is the in, maybe in this building. So but I cannot say physically inside the building. So if you have a router, maybe one router in ABC one here, but if I connect one physical cable, go to ABC two, and they're just using a switch, then do you think it's two different LAN or one? So they are WAN or LAN?
If it's a switch, it would be.
Yes, correct. Yeah. No matter how, if we are under the, like, as I under the router, it's a root, right? It's a root. So everything, even though we are physically, like maybe two different buildings, but if we have the LAN like under a switch, we are connected to the same router. We assign the, if you remember the IP address. So how can we know it's same LAN? We're always like looking at the IP address. Also, it's one about the subnet mask. And here's the slightly, yeah, just back to the IP address. So we know the IPv4, and because really start from 2015, they realized we have getting more and more devices, especially we have more cell phone. And they realized, okay, we don't have enough IP address. When they decided, they didn't expect that we have so many devices require need to assign IP address. So that's why we comes out the IPv4. So it looks like maybe enough in this moment, but when getting more like IoT, suppose in, you know what's the IoT? Anybody know?
Internet
No.
of Things.
Okay, there was Internet of Things.
This is the,
Yeah,
so it's like the smart light bulbs, like toasters, refrigerators being connected to.
okay, yeah. So basically, maybe I say like some sensors or like some, they will receive the IP address, but they don't have like really have some application. So they are more like have a single or like simple function, can be used like only on off, like sending the status. So they like detecting some for certain status, then it will be Internet of Things. Okay. And maybe more can be, how about we have some like cameras, how about camera? Can be either IoT, yes, you can, yeah, because camera just recording and that's it. We, even though we can set the IP address like recording, but we can still consider, is it? Okay.
You can reiterate what the difference between a router and switches. I'm stuck on that a little bit.
Yes,
Like just the different, like the different functionalities of what a switch does versus what a router does.
okay,
Because they seem like similar, but.
Yeah.
The switch will keep things local. A switch governs the LAN, and a router sends you to the internet in a way, if that makes sense. So if I had 10 computers, but I wanted them all on the same network, I would hook them up to a switch. But if I had a computer that was across the world that I wanted to connect to, I would hook up to that one with the router.
Okay, so the router goes from the LAN to the WAN, and then the switch is just to.
The switch-
Manage the LAN itself.
Yeah.
okay, then, or want to like explain more in details or like based on understanding? Like, will you connect about the LAN? Okay, so Bill, I want to elaborate a little bit more. I would say switch is much more like in the layer, you remember the transport layer? Okay, so for the switch, we are not going to like even higher than that. So it's more like physically when we connected. So it's more like it's a physical connection. So we do have some mechanism to handle, we call a protocol to handle if I want to connect from device A to device B. Make it really simple. If in your maybe in your home, your router, you have I tell you the router actually including the router part and the switching part, right? So it's if there's a 4 ports, that one actually is a switch. I say you already put in 4 LANs to there and connect to 4 devices. So if you have a computer, let's say you have 2 computers and 2 printers. Okay, so I would say AB computer and CD printer. If you want to send a printing job from computer A to printer C, but you already connect 4 of them together. So it's more like switch, it's like physical layers. So I will send this package from device computer A to all other ports. So I will send to computer B and printer C, printer D, because it's just like more like physically network connect together. Yeah. So it kind of like is a bridge, connect everything together. So it's a switch. Okay. So they connect all the devices together.
Does it have to send everything everywhere? Or can it only send to one place?
Here's the depends on protocol. Okay. So for some protocol, we call the broadcast. So football broadcast is like I send it to all the connected devices. So can be a switch can allow it. Or I already know the specific. Actually, we do have a switching table. So I know port well, here we also call it port actually interface, because port 0 to 3 like this 0, 1, 2, 3. They'll know, okay, 0, 1 is connected to MAC address of device A, your computer A. And port 1 is connected to computer B. So actually they do have a MAC, the MAC also they have an IP address. So they will know, okay, port 1 is they have a IP like 192.168.10.15 like this. And then computer B will be 70 like this. So we have different numbers, so we have MAC, so we'll know. And depends on the protocol. Are we going to directly? So the switch is the middleman, just like, okay, I got a message, which one? If you know the old time, really, when they invest the cell phone, how do they know connect to? Let me see. How many people know how it does really actually work for when they make a phone call?
Are you talking about like with the operator?
Yes, the operator. Yes. Okay. So imagine I switch it to like this. Okay, I got a phone call, this one got this, I pop this one, got this. So it's more likely how the switch working. And goes up to higher layer router. What's the router doing? We say, what's routing? We need to it's like we know when, LAN, and then IP address, how we handle all this package. For the function, you may think why it looks so similar, but it's more likely, okay, if I have a package comes out from the WAN, it comes in, then I need to know which IP address should I forward this package to. In switch layer, in transport layer, switch cannot handle it. If no way. So it just like tell me, okay, should I send it to this? Just like basically tell me for this one. But for router, just think it need to analyze. Okay, look at this package, like where should I send it to, or how should I do? This is more like manager. But for this one, say the operator like do this, do this. Then who tell it, and then we need to let the router do it. So we call the router. They tell which route.
Okay, so the router will know where it needs to go, and then the switch just kind of like opens.
Yeah, open, do it, yes.
Okay, so
Yeah.
like this road is open,
Okay.
so the data can go here, but okay, well, the data needs to go here, so then the router will see that, the switch will change to this is open.
Okay,
And
yeah,
the router will send.
okay, yeah,
Yeah.
yeah. Yeah, more like
Okay.
this way, yeah. Well, I know because for physical, so there with the so if we say router actually in the higher layer to process the information, the data, yeah, but the switch more like lower, like closer to the physical layer to handle just like connecting, yeah. Okay. And right here, there's some we can use for checking your IP address, and you can try to do it if you want to check. You can open the PowerShell, some your terminal, so we can check your IP config. pretty long time ago, because sometimes we need to refresh or change our IP address or get our own. So sometimes we can do the IP config fresh, like or get any new IP. So we can do it in this layer. And also from our phone, we can go to your Wi-Fi, click on the information, so you'll know which IP are you getting. So you know even like which router, what's our router address. So when I click on it, so we'll know, okay, why now we connect to which router. Maybe we'll like even the router right here, maybe just a subnet. So maybe we are still but when we consider actually all the subnets, we also goes up to the WAN, like it's like out of your local network is called WAN, and that's it. Yeah. So next, you will hear the term I talk about the DNS, right? So DNS, what is called a domain name system. For the domain name system, when we type maybe we call the google.com or like Amazon, even the AWS, when we connect to the using the SSH, when we copy. So if you still remember the Ubuntu add, and then we have like there's a bunch of something pretty long, the name. I can show you right here, AW2. Okay, right here. So you can see the private IP DNS or like public IPv4 DNS. So here's the name, right? So DNS is just a translate. Because only remember the IP address is really challenging, even to us. Like more likely DNS is for us to remember. Like if we have certain name, like google.com is more easy for us to remember, right? Instead of like I need to remember what's the actual IP address of it. So this help us to register it. And those ICANN is like more likely is the organization, they help to like maintain. So if you are registered, if you have a domain name, and if you have a host, like right now we are using Amazon, like they provide the called the DNS to us. If you using, let's say, GoDaddy to buy a domain, then how can I forward using this domain connect with your server? Like say if I say powerful online shop like this, then how.com, then how do they know I need to go to this IP address? Because in the network, we only know the IPv4, the public address. Then how can we know that? So we will register it through the ICANN, this one. Most of the time when we using those, we call the domain name, which is the service provider, they also have what called a DNS. They have an option, so you can do it. And you can just like put because using an A record or like AAA record to set it, or you can define if you have multiple. For example, have you tried to access to maybe some company, they have different website for different location, right? So one's for US.US, like they sometimes they put it in the front, like US.com. And then maybe one in UK.com, maybe Australia, AU.com. And they have really physical, not really physical, but they're using the data center in those locations, right? So we can register like base this part. So we know, okay, if I put it US.com, I know it's forwarding to the data center, the server in US. And if we have an AU, then go to another like Australia, and then we put UK, then they forward to UK. Sometimes when UK, if they have a different website, then we may put it in different server in different data center. Okay. So right here is kind of an example. You see the DNS, the root name server will be right here. Actually, most of them, they hold like West Coast, East Coast in the States, or like in Europe, some of the Asia area. Okay. And we heard about a lot, like really understand. We will move forward to the TCP/IP, and then we will stop in this part. Then I will cover the assignment. So I say the TCP/IP. TCP is the transmission control protocol and the internet protocol. So why TCP/IP is more like stable? Because we are using the three-way handshake. So we'll make sure, like, say the acknowledgement to our destination, and destination we send a response, also another acknowledgement, and then we send, okay, then we will say we'll start our conversation. So that's why it can start for the communication sending package. And then when you see a lot. So for example, it's called the HTTP and HTTPS. And FTP is one of the another protocol. So F is, don't know what's, anybody know FTP? I think it's pretty common. Maybe you're able to see a lot. Anybody know what's FTP? Yeah. Yes, so file. So we are sending, if we need to, like, I'm sending files, then we're using the FTP. POP3, IMAP, SMTP. How about this one? Do you know what's this one? Mm-hmm. Okay, so then what's the difference? It looks like they offer the mail. Yeah, this SMTP is mainly for receiving. So if when we connect, I would say sometimes we connect to the gateway. Those gateway I'm using Google. So if I'm using the SMTP, mainly we are receiving the data, the email only. So if I want to use it to send an email out, then we need to also set the port 3 like this. So all these protocol like handling for different type. So also we can use it to send the email. So just like in different protocol, and telnet SSH. That's what we are using. So this is another protocol we are using. So you see, basically I will stop by right here, all those like terms we are using. Then we will go back to the EC2. I know some of you facing a problem, have an issue. Sometimes me too have a disconnected. If you have an issue, try to connect with the instant connect. This one, when we are using the Ubuntu and the IP address. So when you click the connect, you should have a view like this one. If you are missing or you couldn't connect it, I will post one more is right here for the action. We go to the next, I remember instant setting, edit user data. We need to stop your server first. After you stop it, then you can try to copy this one. This one is help you to forward the setting. So I will post this part in case you cannot connect it to your own terminal using SSH. Then we're using the AWS, their own setting. But sometimes maybe you're not able to connect to. So I think there's some issue to, yeah.
I found there's been a little bit of reconnect to the SSH.
Mm-hmm.
Whenever you're enabled the firewall when you're enabled full,
Mm-hmm.
also enabled open SSH.
Yeah, yeah.
Actually get back in. I couldn't find a way in if I didn't remember.
Okay, if you couldn't, right here, if you remember, oops, I need to be connected again. Need to move.
You want to see that error message for trying to connect to disconnect? No.
Okay, right here. Okay. Yeah, because sometimes I know the AWS, they have different limitation. They in their software layer, they will try to, if we only do full, if we don't allow open SSH, then they just go it. Suppose they shouldn't, because the firewall layer, we should open it. So we can do allow. We can allow the. So let's see. And if you couldn't, at least I tried this one. So you can using the EC2, and I will try to figure out like what else we can do more to allow you to connect back to the using SSH. Okay, and here's about the assignment. So the assignment, I will post what you need to do, and just need to. Okay. What you need to do, to those already create your own server. So what you need to do is showing like all those status. I will list like you need to show the Nginx. So you already install it, and the status should be like active and running. And the PHP, FPM also please show the status is running. And also please show the UFW, the status. So please so okay, if to those like who you don't have a server, I'll open mine. So just like let you to run the command line. So you can use that one to use. So I will share this like after the class. And to yours, I didn't tell how to do this part. Slightly challenge. Actually, I make a screenshot. So at the right here, I tell you the security. And then just remember, go to the security groups. Well, here to you, maybe you only have the SSH using protocol TCP. You don't have the HTTPS and HTTP. So that's why when you click on the right here, maybe if you click the open address, it doesn't work. And here's a slightly trick because we didn't handle the HTTPS, and it helps us automatically redirect to the HTTPS. So remember, just remove the S. Because right now we don't have the Nginx, we didn't implement to add the certificate, and we are not going to handle the SSL in this moment. So after the class, I will tell you how to really handle the SSL, also like how to change the server port. But in this moment, just remember to remove the S, then you can able to show this page. Okay, I just telling you to do that because this is just make it slightly challenging for the assignment. Okay, and let's say I don't know how to create it. Actually, there's a tricks like I didn't tell in the class, but leave this part for yourself. If you say, I really don't know how to do it, I don't know how to change the security group, it doesn't work. So when you create it, remember just scroll down, enable these two parts. So actually, I didn't tell in the class, but if you say, I really miss it, I don't know how to change, I think maybe I don't want to change the user group. Because sometimes we do need to change the user group, the firewall policy by ourselves. Let's say if we need to enable certain port, the SMTP, maybe the port 3, because they using, I remember SMTP with certificate will be 995, but they're not open. If we need to set, then how can we do that? We don't have an option for the SMTP Gmail gateway. Then how can we do? Change the server group, the security group. So that's what we need to learn. Not only just like click the button, check it, and then enable, but also try to like change the policy by ourselves based on our need. Because I already make the screenshot, so like all of you can download it, and if you don't know, just follow the setting. Actually, you can see the setting. And what you need to do, just edit the inbound rules. They are already right here. And just add rules and choose which one do you need. So if you want to allow the HTTP, right here we already know the SMTP is using 25. And sometimes the SMTP with the certificate, they're using another protocol. So we need to use another port. So that's how we need to edit. Because for all this, we cannot, it's pretty nice too, because it already tell you like which service, which type we need to use, then just like put the range. And right here, we can choose the one like all zero is like broadcast to all devices in your network. Okay. So all the port. I will post this one as an assignment. So just like make a screenshot of this part. And that's it for the security assignment. So it's like pretty easy and not difficult. And I will give you a 1 week so you can submit it. If you have any issue, I think if you still have some issue, connect to the server. If it doesn't work, so you can send me an email. Yeah.
I have a question. When you say send me an email, there's no syllabus uploaded in the.
No
email,
syllabus.
So what is your email?
You can also get to it from the class list on YouTube.
Also, if you look at the first page of my suppose DSC, yeah, right here. So like all the PowerPoint, like last page, I will attach. I think even the first week.
So we
Right.
just-
Yeah, here's is my email. And the last page is my email, so you can just get, okay. And in the class list, if you log into the my Leo class list, you should find able to communication class list right here. Then you should able to see me right here. Okay. Yes, only a screenshot, so you can submit in the. Mainly if you have a screenshot showing all those service package, they are running. So just I make the status, show the status. I already give you the example. Then that's enough. So
You don't have that posted as the time.
yeah, I will do it like, yeah. So I would say like put a screenshot, the status and what I expected, what I need. So it is not difficult. So once you already install it, you are good. Just like screenshot the, I say I just need to show the status is active and running. So it's good. Okay.
I sent you an email the other day.
Yeah. Okay. Yeah.
Did you get a chance to got it?
Yeah, I
Set my AWS, like, I thought part that happened, but you know, really had to put this on.
Okay.
I know.
Ah.
I'm behind.
Okay, and after this, suppose like maybe tonight or tomorrow morning, and then I will post the server I'm using. So what I need to do, just I wanted to need to know is the, because actually if you follow all the,
Been watching the videos.
yeah, so all the steps, you already able to install it, just like you already put it install. Just then you need to have a
I got set, but you got set up, you know, there's this stupid card and
Mhm.
that.